So next we have Allan, who's going to talk to us about tiled.
Hello, hello. There we are. Good morning. On the, I think it was the third talk of the conference, you saw Dylan McReynolds showing off some really interesting visual ML applications, and he was kind enough to mention that tiled played a part of that in the back end. In this talk, I want to set the stage for the space that we think our project is in, the space of data and metadata services, and then just a little about the project itself. So there are many people working on what I would call data services. Many of these you recognize, they're of this community. Some you may not recognize, they're from our counterparts in climate science, fields like biological imaging, astrophysics. Why are people spending so much time trying to write data services? Well, you might first think about big data or AI. I first think of simple lab bench experiments, maybe a user who goes to a facility with a box with 3 samples in it. That's what I used to do. We might call that small batch artisanal data. And even at the small scale, I think data services have some room to remove the friction and keep the scientist thinking about her science and not getting distracted by a bunch of I/O details. But of course, at the larger scale, AI, ML, big data, to tackle some of these multimodal problems or analyses that go over a large swath of data that's been taken at an instrument over time, data services are almost necessary to make that practical. And they can do some things to make it more practical to follow the spirit of FAIR as well. This is an article from The Verge from a couple years ago. The reporter interviewed an astrophysicist, among some others, who said that her undergraduates around 2017 started looking a little uncomfortable navigating through folders of files. And this is a little bit wild, but these undergraduates, who would by now some of them be graduate students, grew up expecting a search bar. And maybe more fundamentally than that, they expect interacting with their data at a higher level of abstraction to see the things that they're looking for and then be able to immediately use them in the programs that they're in. In a way, files and folders were an analogy that fit the original transition to PCs from people who were using actual files and folders. These are all just analogies and abstractions to a degree. Think about music apps. When I was younger, we had Kazaa in the year 2000. We were downloading MP3s, MP4s, FLAC if you're a music snob, and you had to care a little bit about what programs would be able to open those formats and figure all of that out. You had a little bit of metadata. We have some columns here that are giving us a little bit of a data catalog on that. But now there's just so much more. Spotify has a deep metadata index. If you search, you're going to hit results based on the lyrics of these songs, way more than you could fit into a file name, way more than you could present in a UI. So if coming back to data access models, I think about SFTP, straight file transfer protocols. You get whatever you can fit into a file name. Then I think about SciCat, where there's a richer database there, and these other technologies, right? They can do rich search. They know more than just the file. But I'm more interested in data services that know a whole lot more about that file. We saw H5 Grove can slice into the file, for example. Tiled is trying to do this, these other projects. They know enough about the data set to navigate inside it and be able to do something with its server side before they send it. So while file catalogs give you the nice user interface, they can certainly do search, they have to stop at file-based download. You download the whole file, then you can look at it and do what you need to do with it. They also tend to emphasize cross-site replication, putting data where it needs to be with queries that look something like that, right? With a structured data service, you have to know a lot more. There's a lot more going on there. It's a heavier thing, but it can support more. There doesn't have to be a file. Maybe your data is streaming into a database or a Redis or a blob storage in the cloud, or maybe it's even still in the memory of the detector. The service can abstract over all those different locations where there is no file to download per se. It also knows enough about the file to give you chunk-aware and partial access to slice into a region of interest and decide if this is the data set you want, or to farm different pieces to different workers in parallel, these kinds of things. Finally, it can transcode the data. If it's written in format optimized for the detector or chosen by the vendor, whatever reason, and the application that you'd like to work with it in or visualize it in doesn't happen to know that format, a structured data service can open the file on the server, transcode it, send it. So we can think about URLs that might look like a slice into the data, requesting a format, or grabbing columns of a table, and again, requesting a format. I don't want to take the analogy to Spotify too far. We are scientists. We like to be able to take things apart. We like to be able to go down a level of abstraction. Spotify will never let you see how that data is being stored, and in a sense, you don't own it. With our scientific data, we need to own it. We need to be able to drop down, and there's no problem with that. So for performance reasons or for just I don't want to deal with this structured data service reasons, you need to be able to extract from the service, okay, but where is the data actually? And if you have direct access to it, then get it, or get the service to just give you the underlying raw thing. That's not something we have to give up in order to get these additional ways of looking at the data. So file catalog, this is a little bit of a cartoonish representation, but I think it says something true. Basically, you get a blob of metadata in a database and a file path. If you want a structured data service, you have to do some more work. You have your metadata, but then you need to describe the structure of your data. If it's an array, what's its shape and data type, so it can be described and sliced. If it's a table, what are the columns and their types? Something about the format, something about if you're talking about data within a file, like a particular data set within an HDF5 file, how to get that out. And then finally, one or more locations of the data. So you get more capability for a lot more information stored in the server. Our implementation of this that we're calling Tiled is an HTTP service that supports reading and writing data. In parallel with developing that server, we have a Python client that's meant to feel like a sort of generalized H5Py to use. So it's fairly comfortable for scientists who are already working in that mode. And then we have a proof of concept React app to show the web integration aspect of this. And there's even a small but budding ecosystem of clients to Tiled that we were not involved in writing, which is a nice validation that this can be done. So here's the server in brief. We've got authentication. If you're an automated job, you maybe want a simple API key. If you're a user, you want OAuth 2 refresh flow. We need some pluggable authorization. Each facility has rules for which users can see which data may be related to their proposal system. So that's a pluggable thing that Tiled can do. And then there are very mature standards in HTTP for this negotiation of how you're going to get your data. You could say, I'm a website, so I'm a browser, so I can display PNGs for this image, or if I'm getting a table, I can display CSVs, and I understand gzip compression and Z-standard compression. Or if you are a C++ program, you might connect and say, I understand C-ordered buffers, and I understand BOSC compression or LZ4. And Tiled can do that translation to send the data in a format most efficient for that client. On the back end, it's accessing data storage, maybe on a file system, maybe in a database. It's got its own database of the metadata and the things on the previous slide. And of course, it needs some database to manage its authentication information. So this is the Tiled server and what it's up to. This is the Python client. The Python client looks a little like H5Py here, you can kind of see, but what's different? We're connecting to a web server instead of opening a file. And then the data model is a bit different. The data model for Tiled can have extremely wide containers. So you're accessing the data in a way that is filterable and sortable and can be drawn through in a paginated way wider than an HDF5 group. You have array structures, but you also have tabular structures with Apache arrow semantics. You have sparse arrays. You have what the high-energy physicists called awkward arrays, structures that are good for nested event-based data. And here's a look at the React prototype, where on the back end we have a Nexus file that came from a detector, but the web browser doesn't know how to display that, so you get a sliced, downsampled PNG that loads real snappily. Here's an example of a scientist-written Igor client. There's even another one at the APS. And at the end of the day, it's just a web service with OpenAPI documentation. So anything that speaks HTTP can speak to this structured data service. Emphasizing again, you don't have to go through HTTP. So if you're remote, or if you want the nice interoperability of HTTP, so many things can do HTTP, then maybe you're downloading and uploading your data through HTTP. But if you've got access to the underlying data through Globus, or if you're just mounted that GPFS, if you're local, then maybe you want to use Tiled as an index where you can just ask it, no, just now that I've searched for the data, tell me where the underlying assets are, and I'll go get them. Or you've got a detector or some data processing pipeline that writes the data in a high-performance way. You don't want to upload it. You just want to register it with the data service so that other people can search for it and download it that way if they like. This is an open source project. We're trying to design it inspired by the Jupyter project in a way that scientists can run it on a laptop, facilities can deploy it at scale. It's meant to be a very portable tool, not an NSLS2 thing. We have built this out of the Blue Sky project, and so it's currently under the Blue Sky multi-facility governance model. This is where we're aware it's being used. If it's being used elsewhere, definitely let us know. I want to emphasize we take the security very seriously. We have a private company that is periodically testing that this is as secure as we want it to be. There are many people who have put intellectual input as well as code into this project. This is not a list of all the 38 contributors, but some who've made some of the biggest conceptual contributions to the project, spanning especially NSLS2 and ALS, some industry partners at Anaconda, and our friends in the high energy physics community. So to sum up, data service searches on the metadata, can slice into remote data sets, can transcode between different formats, enabling you to download partial or whole data sets, or just go around and find where the data is stored if you can get at it directly. It implements web security standards and authorization. Importantly, it does not implement data reduction in a general way or workflow management. This is not a data processing tool. It's really limited to just transcoding, converting formats, and downsampling. We don't want to have an explosive growth of trying to do all those other things, but Tiled could be combined with workflow management tools, we think, in a nice way. So here are some links. The QR code will bring you to the docs. There's also a demo deployment and some code. Happy to take questions if there's time. Thanks.
So I liked your music analogy at the beginning.
Thanks.
If I pick up on it, Napster, I was getting songs I shouldn't really be having, right?
Yeah.
So with Tiled, what's your approach to queries? Do users see everything and then kind of end up, again with music, on a paywall of things I can't actually access, or do I only see what I can actually access?
Right. So you can deploy Tiled as a fully public data service if you want, and that's nice for tutorials and demos. But for a facility, there's this configurable access policy that is effectively applying a search filter that the users can't opt out of. So they're going to start with a pre-filtered set of search results based on what they're allowed to see, and then they can further filter from there. That's true. That's a matter of facility policy, whether maybe the metadata could be public, even if the data is not. There's no reason that couldn't be done. Yeah.
Thanks for a great talk. I
Sure.
just was wondering, do you have is there anything foreseen to support stream data, so data that's in the future even?
Tiled cannot access data from the future, but it can. But we are really interested in streaming, right? Yeah, streaming is a big part of what Blue Sky is trying to push, and so streaming access to data is of interest to Tiled. Yeah, thanks.
Let's thank Dan again.